All right, let's dive in. Welcome everyone to the latest HRAI webinar. Today we are joined by André and Henry with RefPlus. They're going to be taking us through a really good, dense presentation on CO2 condensing units, during which you'll have time to send in your questions through the Q&A button or the chat, and we will get to them in real time as much as possible, or save them until the end. But without further ado, you can see them on your screen right now. There's Henry and André. I invite you to turn on your mics and say hello.
Hi, everybody. Hi, guys. I hope you're doing well. Well, thank you for taking the time on your lunchtime to listen a little bit of information that we have to give you on our condensing unit. Maybe first of all, talk about RefPlus. RefPlus been in business for the last 30 years, and we've been in the CO2 market for the last 10 years. We've been supplying evaporators and gas coolers to our OEM customers out here in Quebec. So we have a lot of experience with these with the CO2 unit and circuiting. Nice thing about it is when we looked at what was offered in the market, the CO2 didn't have really a product offering on the condensing unit side. So we've elected to work and develop a new condensing unit for a CO2 market. Today, myself, André Paré, will be presenting really a small part of the presentation, but Henri-Julien here will be doing the most of the presentation. Henri is our R&D project manager for the condensing unit product. So he's well in tune and well aware of everything that we've done on it. So feel free to ask questions to Henri. First thing, if we go through the topics that we'll be discussing today, why are we going with CO2? So we'll do a brief, maybe a resume of the reason why we think that CO2 is one of the way of the future. And that's why I'm saying one of the way, but it's definitely going to be a solution for us and for you guys. Then we'll talk about what's being done with the CO2 in the industry, jumping finally into the condensing unit, talk a little bit about the adiabatic gas pre-cooling for the condensing unit. So we'll see how we install it and use it on our units. And finally, the low temperature application. So I'll pass now the presentation to be continued by Monsieur Henri. So go ahead, Henri. Thank you.
Thanks, André, for the introduction. So probably that everybody in that presentation already know that the CO2 is an A1 natural refrigerant. So it's non-toxic for humans, non-flammable. The global warming potential equals to 1. The ozone depletion potential is 0. And there's no P-phase resulting from the using of CO2. So those are the main reason, but let's say that there's also commercial reason for using CO2. One reason is the availability and the predictability. So the CO2 is cheaper compared to synthetic refrigerants. So the CO2 isn't produced by chemical companies, and it's available through industrial gas suppliers, meaning that even high purity grade CO2 is less expensive than any synthetic refrigerant. So if you're calling right now your local distributor and asking for the price for R448, you will see that you're going to be probably 10 times higher than CO2 with the same quantity of CO2.
And there's a lot of variation in that price. You've seen the refrigerant price last year went up really really like in a very big way. And with the new limits that you're going to have with refrigerant, that $23 will most probably be increased by 50%. And maybe in the next 2 years.
Talking by limits, probably most of you have start getting knows about A2Ls. So CO2 is also a way that you can get rid of the never-ending refrigerant phase-outs by offering the end user a long-term solution. With new regulations phasing out HFCs, A2L is now considered probably as a future replacement solutions. Local codes, authorities, insurance companies are now trying to define the regulations for the use of A2Ls. But at the end, the CO2 is non-flammable, non-toxic, and already used in several plants across the world.
So mind you, we want to also say that RefPlus is working presently on an A2L product offering. So we will be jumping on board with the A2L product. But we foresee that with the CO2 product offering, there's much more stability for the end user and even for you guys out there in the market, the contractors.
When you're talking about CO2, stakeholders are always concerned about high pressure. So it's important to know that components and material used for CO2 is designed for high pressure and high temperature, especially for using the CO2 in the transcritical states. This is the same for the assembly. The companies are using brazing and welding procedures that allows the use of higher pressures. But 95% of the time, if you're looking to locations in Canada, the unit will run in a subcritical state, meaning that you're having higher tolerances for your unit than you need to, in most of the time. There's another concern, which is the using of the PLCs and electronic controls. Of course, the addition of controllers increases the cost of CO2 system. However, controllers are an important part of the modern system because they allow smooth and effective operations. And also this is an added values in terms of alarms, data loggings, and it's allowing the contractor to have remote control of the equipment. So it's always good to know that an equipment is stopped before receiving a phone call from the customer because the cold room is getting warmer. Talking about the industry. So CO2 has been used in many refrigeration projects since 2010, mainly in supermarkets, industrial projects as well. And it was typically in booster rack systems. That brings some challenges, which is the transcritical and subcritical operations. So control systems need to be well adapted to operation systems. We're not talking anymore about the liquid receiver, but more as a flash tank. So the pressure of the flash tanks will be different from the gas cooler than in the flash tank. There's a part of the vapor that needs to be evacuated by the transcritical compressors as well. Compressor superheat is crucial, and a special attention must be taken for all separations. So if you're looking to a typical CO2 booster systems, you'll see that when you're looking to the diagram, it may look simple. So you have your low temperatures with your first stage of compressors. Then this goes to the high stage of compression with the temperature below the 2 stage. Then from the mid-temp compressors, you're going to your gas coolers. From the gas cooler, you have your high pressure valves. This is one of the new components used in the CO2 systems. Then you're going back to your flash tank. In the flash tanks, you have part of the vapors going back to your compressors through the bypass valve. And there's a part of liquid also going back to your different evaporators. And for that system, many controllers are needed to make sure that the system is working well. But if you're looking to a real rack, so it's maybe it's kind of get confusing let's say that system can get confusing. So when you're looking to a rack like that, you're able to see the same compressors stage. So you have your medium temperature compressors below the low temp compressors. You're able to see that you have two VFDs, one VFD for each of your stage of compression. You see oil separators. So we're able here to see the oil separator for the subcritical compressors. You have also oil separators next to the flash tank here, but at the back. You have here a small unit, a small condensing unit, and this is in charge of getting the pressure in the flash tank less than 45 bars. So that condensing unit needs to be connected to a generator as well. You have many circuits, many liquid line and many suction lines. You have two pipes going to your gas cooler, and you have another pipes that is coming from the gas cooler to your flash tank. And as you can see, also the control panel is pretty big to make sure that you're able to control every IOs of this rack. By the way, this is a rack from the company Septec, which has been newly acquired by RefPlus last week. And they are specialized in rack systems with the natural refrigerant. So they're in business for more than 10 years now.
So the system shown here is a 45 bar low side pressure. This is why we need the auxiliary condensing unit to maintain the pressure under 45 bars on the low side.
You also need an oil tank to fulfill all the compressors with different pressures. That's why we're coming with our solution. So for the last 3 years, we've been developing a condensing unit using CO2. We've designed, built, and tested more than 5 prototypes with different applications for each prototypes. Basically, it's the same footprint as our old condensing unit, but there's slightly differences in the way we need to add some components to make sure that the system's working well.
One main objective that we had was to build a condensing unit that was really simple. If we compare it to our parallel pack, so that was, we went from a design that was more complicated with a lot of different valves that really definitely looked like your parallel pack. But then we've trimmed down all the different valves and tested what we've done to make and design a very simple condensing unit. A little bit more complicated than your synthetic condensing unit, but much simpler than your parallel pack.
So one of the strategy that was always in front when we try to design those units is to keep in mind to be really designed for maintenance. So we're trying to keep in mind the contractors that will use our condensing unit. So as you're able to see on that picture, there's access doors everywhere on the dugouts. So it makes the service easier for the contractors. So this is a view inside the dugouts. So as you're able to see, we're using a oil separator with a oil tank integrated. It's quite the same with the synthetic refrigerant, but it's 140 bar unit. So it's really it's built for high pressure. You have suction accumulators, it's like the same as a synthetic refrigerant. You have a compressor, liquid dryer, but every component that you are seeing right now is never less than 90 bars standstill on the low side and 120 bars standstill on the high sides. We designed those units with the 3 main compressors brand. So we're using Bitzer, Copeland, and Doran. we've built two applications for the moment, which is a design for low temp and a design for medium temp. And finally, the dugouts and the unit is painted white.
Puts over there.
Yes.
One point that I'd like to maybe make sure that is understood, the 90 bar on the low side, what it does, it allows us to get rid of the emergency condensing unit. So we didn't want to have on smaller condensing unit like this, like 30 horsepower or 60 horsepower system, to have a second condensing unit to allow us to operate at 45 bars. 90 bar will, the system, the condensing unit will be able to stand still up to a temperature of 105 degrees Fahrenheit or so on the roof. So this allows us to do the repair without losing the CO2 refrigerant charge into the atmosphere.
I have a small video that shows the unit. So here is another example of a rack. So as you're able to see, you have your two oil separators for your medium temp applications, the small condensing unit, oil receiver, two compressors on the low temp. And here's the condensing that we've developed. First fan will always be a ECM fan, allowing modulation for the gas cooler. You have the possibility to have adiabatic ramp also. If you're looking in front, you're able to see the control panel. So you have our controllers. It's a Carrel controller. We're having the VFD also for the compressor. And as you're able to see, we keep in mind the design for maintenance. So we're keeping the controller and the VFD split of the power, the power panel.
High power, yeah.
So here you're able to see the same picture previously shown in the presentation. And when you're looking on this side, you're able to see the high pressure valve, the flash gas bypass valve. This is a heat reclaim also. It will be an option on our units. So there's also advantage when it comes to speak about installation. So as any other condensing units, you will have a shorter piping run between the unit and the evaporators. So sometimes in projects, you have mechanical rooms that they can be like more than 100 feet from your evaporator. So it brings the installation cost higher.
For the parallel pack.
Yes, for the parallel pack. It's reducing also the required size of the mechanical rooms. I mean, it's making sense because you don't have to install the rack in the mechanical room.
Hi, guys.
Yes.
I just got a question from chat about the condensing unit. Is that condensing unit, I'll read it verbatim. Is that condensing unit only either MT or LT in the same time?
No, we've developed a solution that is medium temp or low temp. We're trying to developing a solution for dual temperature, but for the moment we're only doing low temp and medium temp.
And one more follow-up question: who is the manufacturer of this unit?
This is RefPlus.
So it's okay.
We're building the gas cooler. We're building also the dugouts and every components, the structure. Of course, we're using compressors from Copeland, Doran, and Bitzer, but otherwise we're really building those units.
Thanks very much.
You're welcome. One of the big advantage that differs from using a rack is also the fact that normally a rack need to be connected to the gas cooler. you need a high pressure welder. So it's another type of contractors. For the condensing unit, the CO2 condensing unit, the gas cooler is already built in and connect to the unit. So no needs for high pressure welder.
Yeah.
Yes, out of the factory, exactly.
So it's a package.
So as you can see, there's an example, kind of an example of how it can be plugged on a project.
Connected,
So,
yeah.
Yeah, connected. So you're able to see evaporators, the condensing unit. So like I said, the gas cooler is a part of the unit.
So the only lines you have is your suction line and the liquid line. In this example, we would be using electric defrost. So we can go up to four evaporators
Yes.
on a single condensing unit.
There's also advantages when it comes to speak about maintenance. So we're using a Carrel compact controllers. So it's a standalone controllers. We're able to do all the IOs with one controller. You have the remote access to the control panel. You have fewer components. So we're not increasing the amount of components. We're reducing it. So it's a good news when it's time for maintenance. Yes.
Another quick question. It's coming fast and furious now. What's the minimum capacity for MT and LT for that condensing unit? And do you have something for C stores?
Not for C stores. This is a question that I've been bringing to our attention. We're developing a unit right now, trying to have that kind of capacity. We're a little bit higher in terms of capacity. What I'm going to do is I'm going to show you at the end the capacity that we're having developed right now. So you're going to have all the different capacity that we're able to achieve. But yes, the C star is something that we are keeping in mind. Is that okay?
Yeah. That's great. And I'll just
yes.
Yeah, I'll just keep monitoring the chat. And that's just a reminder, if anyone has questions, just pop them in there and we will get to them when we can. Thank you.
So as I said, fewer components. We're using simple electric defrost. So we're able to defrost our evaporators with electric defrost. And finally, we're 90 bars standstill pressure on the low side. So meaning that there's no need for emergency backup unit. And with that, there's no need for generator as well.
So on the adiabatic side, the adiabatic pre-cooling is available on our condensing unit. What we'll do, we'll increase your capacity on medium temperature quite a bit, lower also the energy consumption. If you have a like summer condition of 95-degree Fahrenheit dry bulb, 75-degree Fahrenheit wet bulb, you would have or produce the equivalent by pre-cooling the air with water. It would be the same as having continuously air at 79-degree Fahrenheit entering the coil instead of 95. So one of the challenges with CO2 is that you always want to have that gas coming out of the gas cooler to be below 100, 103, and never really above 105, because that's when you reach the limit of having a high temperature coming out of the gas cooler. But with the adiabatic, it ensures a really nice, stable operation, even when the temperature reaches 95 or even above. So there's never a concern with the adiabatic of reaching these high temperature where your system could stop. So once again, reliability and efficiency are looked upon in doing so. Maybe the other slide. So you can see on the right hand side the reason why we can do adiabatic on our flat gas cooler, and we do the same on our condenser and on our fluid cooler. And we've used the adiabatic for the last 7 years this way with nozzles and atomization of water. So the thing is that we're not using the pads that most of the manufacturers are using for adiabatic pre-cooling. So that way we can do it for a smaller unit without having the problem of getting a vertical coil or at a A-type coil that other people use when they have the pads. There was a question there, is RefPlus located in Saint-Hubert, Quebec? Yes, indeed. It's in Canada, in Quebec. We have a few plants, one in Saint-Hubert, one in Saint-Bruno, and a couple of also plants in Boucherville. So it's all around the same area on the south shore of Montreal. It's privately owned by Mathieu and a group of private owner, Mathieu Cardinal, which is a Canadian guy just living here outside our office in Saint-Hubert, so Canadian owner. Ness is not the owner anymore. That's a funny question, okay? And if Ness is listening, well, I would say bonjour to Ness. Really appreciate it. I worked for Ness when in the good old days with Blanchard Ness with Michel Lecomte, our R&D manager. So coming back to adiabatic, sorry for that. We have a filtration system before that, so we're pre-filtering the water to get rid of the minerals inside and also get rid of the particles. So the nozzles are always nice and clean. And a lot of people are asking us about winterization of these. We allow to drain all of the system which is installed outside. We allow it to drain every second day that it's not being asked to operate. So if ever your system stops in August and temperature outside is under the limit where the adiabatic is needed to pre-cool the air, well, the system will simply drain down inside, so there's never water staying there for a period of time or a longer period of time of 48 hours. We'll just go to the other slide.
So talk about low temp applications. Maybe it was the questions before was regarding that. How we're able to do the low temp without using two compressors is that we're using Dorin semi-hermetic two-stage compressors. So those compressors are working with a pair of pistons that build pressure from the low stage to the intermediate stage. And another pair builds the pressure from the intermediate to the high stage. And RefPlus is using an open flash tank design combined with a desuperheater to be able to achieve the low temp application. So if I'm showing you
the video,
yeah,
another video showing the cycle.
So here is a really simple way how the system is working. So you have your first stage of compression. So you're able to see the gas that goes from the low temp evaporator, then entering to your first stage of compressions. You have your oil separator on the first stage, and then you're going to your intermediate or your desuperheater cooler. You're going back to your flash tank, and a part of that vapor is going back to the second stage of compression. Then after the second stage, when you're in high pressure, you're going back to your gas cooler. So the gas cooler is having actually two sections. So there's a section that is doing the desuperheater, and there's a section that is doing the gas cooler.
Mm-hmm.
You still having your high pressure valve, and then you're going back to the flash tank. Just for your information, the pressure that you're having in the flash tank will be the same in the desuperheater. So it is represented by the line that we're having here in the pH diagram.
All right, I got another one for you.
Yes, go ahead.
In our area, it is hot in the summer. Do you have other ways to increase efficiency in transcritical mode other than subcooler or adiabatic cooling? Did I pronounce that right?
Unfortunately not. We're able to have good COP with the pre-cooling system, with the adiabatic pre-cooling. We're always using subcooling on our systems, even if the temperature is not that high. But actually, no, where the COP will be maybe affected by that reality. But let's say that we've evaluated that in probably every, like, let's say the highest temperature, depending on the locations in North America, let's say that way, and we've having good COP with using adiabatic pre-cooling system.
Thank you very much.
We're after that going through our expansion valve, then it's the same process as always.
One thing that I may add to answer back, if we're using a parallel compressor ejector, we're building condensing units, so we don't. Our objective is to build something that's as simple as possible to make sure that most of the contractor and technician, when they use our product or work on our product, they're going to feel that's pretty simple to operate. So we're not trying to add a lot of stuff on our units. We're really trying to have a reliable, efficient system, and we're trying to make it as simple as possible for our technician in order to go there and service it in the future.
So if there's a conclusion for that presentation, is that the simplicity of RefPlus CO2 condensing units will popularize the use of the CO2 refrigeration equipment among contractors and end users. We need to put emphasis on CO2 system knowledge and training. It is mandatory. RefPlus is committed to train every contractor that will work with our units at our R&D training facility. The system reliability is a key factor of success and for contractors and manufacturers. And finally, let's build the future of refrigeration together.
Thank you.
Excellent. Thank you so much. Well, I have some lingering questions, if I can throw them out to you.
Yes.
Just some that were collected throughout the presentation. Well, first of all, here's a timely one. When will you start selling those units? That comes from chat.
We're working presently on some beta system where we really want to find some jobs that are really key for it. But if you have some requests on some jobs, let's take a look at it. We're open for discussion. Obviously, we need to have a group of owner and contractor that are really willing to get into the system. So we need to talk, look at the install, and then jump into it. But our pricing and availability of the product is presently everything is available now. Yeah.
Perfect. Can you do me a favor, Henry, and put it back to slide 13 if you got a second?
Yes.
We can do that. Yes, there is a couple specific to that slide.
I think it's this one.
I think so. So two things for this. Are you using your standard evaporator for 90 bar low side pressure for this?
The evaporator, our standard evaporator are, designed for 650 PSI. So that's kind of 45 bars. So for 90 bars, we use for electric defrost, stainless steel half-inch tubing. Yeah. So that's not our standard synthetic refrigerant evaporator.
And on the same slide as well, what is the effect of having white painted unit instead of galvanized steel?
Well, it's just because we've tested the two different finish on our dugouts, and we've been able to see that there's more than 10 degrees C of difference of the temperature inside the dugouts, which is considering. And that's why it's a must to have a white paint coat for the dugouts.
So it's a little bit like having a roof with a white covering on it instead of a black one. So the black one will be much hotter, warmer, because it holds the le rayonnement, the effect of the sun on it, and the white will reflect the effect of the sun. So same thing for the unit.
Thank you. You skip forward to slide 16. So for this one, a question came in: why aren't you using Copeland Emerson or microthermal Parker controller?
Well, we are developing solution with other companies, but actually we use Carel controllers because it was a compact controller where we were able to do to get all the IOs to one simple controller. It's kind of standalone, so that's why. And the other thing is that we're working with Carel for the last 10 years on other applications. So it was easier for us to work with Carel at the start.
That's great. Those are the questions we had. And if anyone listening would like to ask more, now's the time to do so before the presentation concludes. Now, yeah, if you could put up your contact information again at the end there. Sorry, I know I'm making you go back and forth in your presentation.
I'm not sure we're having the contact information. You're having our names, but
okay, yeah, no
we'll
worries.
have to share that.
Yeah, we can share that with you guys after the fact. I'm just going to go back to webinar chat here. Any pressure switches used in such units? Maybe
Of course.
Chat there, yeah.
Of course, we're using a pressure switch from Copeland now. Those are pretty much the same pressure switch that we're using in the synthetic refrigerants, but it's pressure switch that is built for high pressure. But it's the same way it works. We're adding high pressure switch the same way as we're using high pressure switch in the synthetic condensing unit.
Great. Maybe you can see in chat there, André. There's kind of a series of questions that you might be better equipped to handle.
Yeah.
Looks like we're wondering which models the pressure switches are going to be used in the encapsulated ones. You see that on your screen?
I don't know, André, are you seeing the question on your screen?
I see it. I don't know which model it is exactly. Sorry.
Yeah. Okay. No worries. Oh, we got one in our Q&A. Regarding the pre-cooling of the condenser air, is this a wastewater system?
Is this a what?
Waste of water system.
This is a wastewater system.
Waste of water system. Well, you could use a gray water on it, because we have a filtration system that will allow to use that. But obviously that the water cannot be brown water, if I may say. It needs to be clean. Yes.
Yeah. Yeah, it was wastewater system, so I think that covers it. Wastewater meaning once through, I think, in terms.
Yes, our system is it's not recirculating. The water's coming from its city water going through it and then being atomized directly. So there's no recirculation.
Thanks for the clarification.
So we're showing here the catalog to go maybe to the capacities.
Exactly. So here it is. So you have the example of the capacity that we're able to reach right now with the model design. So this is the capacity for the medium temperature. So if you're looking, let's say at 20 degree with an ambient of 95, you will be around, you can achieve from 100 MBH to 200 MBH. We're having the same. Yes.
So also our compressors, they're driven by a variable speed drive. So that capacity can be reduced by quite a lot. So if you're balancing your system at just let's say a little less capacity, we're able to fine tune that. So we have a low capacity and then a range of capacity within we can do the selection.
And if you're looking here, it's quite the same capacity, but it's with Emerson. Well, it's now Copeland.
Copeland compressor.
Should say Copeland compressor. So this is probably the same capacity. The only difference is that we are having the 28 ME, which allowing you to have a little bit more capacity for the Copeland ones. And for the Doran, you're able to see the low temp applications. So if we were looking to the same, but at minus 20 of SST, you're able to see that we're going something from 70 to 110 MBH for the low temp application.
Okay.
So this is our single compressor design. We're working on a two compressor design that will be coming up soon in order to increase the capacity.
Thank you so much, guys. I think that's it for questions, unless someone wants to get a last one in. But I wanted to thank you guys for doing this presentation. A lot of good information. And if someone wants to watch it again, just head over to our HRAI YouTube page afterwards and give it another play. You got a thank you, fantastic information from chat there as well. So,
Okay,
Thank you very much.
good audience review. Yeah, thank you, Andre, Henry, so much. And for everyone listening, we got a bunch more webinars planned for the summer. I know it's your busy season, but if you have an hour during lunch, you can catch some good stuff coming up. Check out hrai.ca/events.
okay.
In the meantime, thank you so much, and we'll hopefully see you guys again soon.
Okay,
Thank you very much.
How many people that we had at the maximum there?
We had over 30 people watching, so that's
Oh yeah, well that's good.
audience.
That's excellent.
35
Okay.
person.
Yeah.
Appreciate it. Okay,
Thanks.
take care. Thank you for the invite.
Thank
Thank
you
you.
so much.
Bye-bye.
Take care. Bye-bye.